In this video, I will discuss how to design PCR primers that will amplify a DNA sequence. To start off, here is an example of a short segment of a double-stranded DNA sequence. We have the top strand of the DNA, which is the coding strand, that is in the 5' to 3' direction. Below that, we have the bottom strand, which is the template strand, and it goes in 3' to 5' direction. Now that we have the DNA strands established, we can go ahead and look at the DNA sequence we want to amplify. In this example, the part of the DNA sequence we want to amplify is underlined. We want to design two primers, a forward primer and a reverse primer. Starting with the forward primer, it will anneal to the template strand, which will enable the synthesis of the coding strand in the 5' to 3' direction. The primer binding site for the forward primer is on the template strand, where it will bind and synthesize to the right. This means that the forward primer must be complementary to the template strand. In this case, the forward primer is 5' AGT 3'. Now that we have the forward primer, it is time to design the reverse primer. The reverse primer will anneal to the coding strand, which will enable the synthesis of the template strand in the opposite direction. For the reverse primer, the primer binding site is on the coding strand, where the reverse primer will bind to that site and enable synthesis in the opposite direction to the left. In this example, the reverse primer is shown in the purple square. It's normally seen as 3' TAT 5', but you have to remember that it is written in the 5' to 3' direction, so it'd be 5' TAT 3'. Now that we have a forward primer and a reverse primer, we can go ahead and amplify the DNA sequence. When designing primers for PCR, you have to be careful of the direction of the primers. The forward primer should be in the 5' to 3' direction going to the right, and the reverse primer should be in the 5' to 3' direction to the left. If the PCR primers are facing outwards, amplification will not work.